to another informative video with Peak One Builders. Today we're out on our Cinder cone project, and we're going to be talking about floor framing systems, the different types of framing members, as well as different types of sheathing, some of the building science behind it, and the products that we chose, how they're installed and why we chose those products, and ultimately it's for best practice reasons. So I'm going to walk you through the different types of systems that we have here in Arizona, and again what we chose based on best practice. So ultimately at the end of the day, we're trying to create an environment for the homeowner that once they move into the house, they're not going to be experiencing things like squeaks and things like that. And it does come down to budget at some point, so some of the lower end homes require a little more budget conscious materials, maybe not the best materials that I would choose, but at the end of the day, we've got to make a decision at some point, draw a line in the sand. So on this particular project, we've had some opportunity to use multiple different types of framing systems. Up above here, we've got TGI floor trusses. These are commonly referred to as I-joists. They're a manufactured product. So when you get a manufactured product, whether it's an LVL or an I-joist, you're going to get a very true, exact dimensional piece that comes out of a manufacturing process. So these I-joists are excellent for that. They do create a very flat structure prior to the sheathing going on. So there's a lot of benefits to that. I've actually got one here. These are designed just like a wide flange beam. So you've got a plywood web in the middle, and then you basically have a LVL top chord and bottom chord, if you will. These are very strong. They're well engineered. Some of the advantages to them is they do have knockouts in here, which kind of makes it a little bit easier mostly for the electricians to run their wire through it. Some of the drawbacks to it are that plumbers and mechanical have a hard time with a system like this. But in regards to stiffness ratio of a floor, you're taking a manufactured product like this and a subfloor on top of it that depends on what sheathing and the thickness they use is going to create a very stiff, even floor and a very flat floor for your flooring contractor once it gets to that point. But again, some of the drawbacks to these I-joists really comes down to mechanical, meaning the HVAC system and how you're going to run your ductwork through a system like that. On more simple modular type buildings, maybe more square, rectangular, very simple buildings, I think I-joists are an excellent choice. It gets to when you have a building that's all cut up in different elevations and things like that, it becomes a problem trying to get ductwork through there. This particular area of the house, we're basically down in the basement below grade. These are our masonry retaining walls here that we talked about a while back. We've got a big challenge with ductwork getting it through all these different areas. So up above me, we do have I-joists. And because of the shape and some of the constraints that we had with steel, it just seemed to make more sense to use I-joists in this area only. We also have this round element here behind me. This is going to be a wine room. And again, kind of the same situation. That's actually going to be a sunken fire pit, so we had to use a different size joist there as well. So there are some advantages to using the I-joists. Something like this, to do it in floor trusses, you'd have to have a different floor truss for every one of these. So the framers can come out here and cut every one to size and not have to worry about that. That is a huge benefit. And ultimately, that's the reason why we went with those here. So I'm going to show you some of the other areas in the house behind me here, or in front of me, I'm sorry, where they're open web floor trusses. And we're going to show you the advantages to that and talk about that as well. But basically, the other item that we're not going to talk about too much is conventionally framed floor trusses. Back in the Midwest or out east, you may see a lot of 2x12 or 2x14 floor trusses. That type of conventional lumber and conventional framing is still being done. It's not bad. It's just that there are better practices out there, such as these I-joists and open web floor trusses. But conventional lumber has, there's a tolerance to it, just like anything else. So you may get a joist that's, 11 1/4, 11 3/8, or 11 inches if it's a 2x12. And the problem with that is that as you go to put your floor sheathing on, you may have gaps here and there that if you don't glue it and screw it, or use ring shank nails, you potentially are opening yourself up to squeaks down the road. These things typically don't come out usually for a few years after the house is somewhat settled. But the problem with those as well is those joists have to be crowned, meaning the top of it, where it has a crown to it, faces up. All those joists, when they're rolled, have to be, typically we put an arrow on them so everybody knows what direction they go. But probably the best choice for a very rigid, stable and flat floor framing assembly. And again, when we're looking at these different assemblies, the idea is to create a rigid, tight structure where everything acts as one component. So whether you're using a floor truss or an I-joist or conventional lumber, the idea is to take that lumber, that truss, whatever it is, and combine it with that floor sheathing and make a very rigid, flat structure. So you're not getting callbacks for squeaks, which can be very costly. So this is the other part of the basement down here, where we're using a 4x2 engineered floor truss system. This is more conducive to getting ductwork and plumbing and obviously electrical through the spaces in the trusses. One of the big things here, and you can see right above me here, there's basically vertical panel points, if you will, that we have set aside for our mechanical ductwork. We spent a lot of time with the architect and the mechanical contractor making sure that we can get cold air returns and supplies where we needed them. On a custom home like this, if you don't think about those things far ahead of time, it's going to create an unbelievable amount of problems for you in the field. And what ends up happening is that guys end up cutting trusses apart without permission, and then we have to create a repair detail for that, or we have to end up adding soffits everywhere to accommodate the ductwork. So it's very important to understand what the options are when it comes to the mechanical system, because it's the largest piece, the least flexible, typically when it comes to mechanical, plumbing, electrical components that have to be in this floor framing assembly. So with the floor trusses, we're able to sit there and plan these things out, review shop drawings that are created by the truss manufacturer, and put these areas, these runs through specific locations to make sure that when these guys come out to actually do all the rough-in for the mechanical system, everything is there and there's no surprises. We also bring our mechanical contractor out prior to the framing being finished, just to make sure that they are understanding everything that we're doing, because sometimes on paper it gets misconstrued a little bit. So it's important for them to come out during the process and understand what we're doing and to make sure that there's not going to be any problems, and if there are, we can possibly stay ahead of it and make modifications as needed. So the big thing with open web trusses, besides the flexibility for our mechanical, plumbing, and electrical trades, is that they are manufactured product. They're made, by a truss company. So you typically will get a uniform thickness, not quite as tight a tolerances like with an I-joist. You're going to have much tighter tolerances where you could lay 10 of those side by side and they're all going to be the exact same dimension. That's a huge benefit. Sometimes with the floor trusses, there's a little bit of tolerance with those as well. So we have to be very cognizant of that and watch that as we're rolling the trusses. Sometimes we've got to shim them here and there to make sure that everything is flat and one plane across the top before we put our sheathing. So it's an excellent way to help reduce costs as well with the mechanical, plumbing, and electrical contractors, because if they've got to start drilling holes through, whether it's conventional lumber or through I-joists where there's not knockouts, it just creates more time, and those particular trades are going to charge more to do that. So anytime we can use an open web truss, whether it's a floor or a roof, we're going to do that to take advantage of that as well. So and it just offers a lot more flexibility, because a lot of things at these custom homes are changing as the process moves on. So I think it's real beneficial to use a system like that. And ultimately for us, for this particular project, it is best practice. Overall majority of this basement here, I'd say 80% of it is all open web trusses, except for the areas that we were talking about below. We've got some steel in here, so it does complicate things a little bit. The disadvantage to trusses are if you do have to cut something, it's going to require the engineer of record for the truss manufacturer to create a repair detail and basically stamp that so that when the city inspector comes out to do a framing inspection, there's a repair detail for that. But basically, the stage that we're at now, we're starting to sheathe the upper level. So we're going to go up top, and I'm going to talk to you a little bit about the different types of floor sheathing and ultimately what we chose for best practice. So come with us upstairs. So now we're up here on the second floor, or the main floor, however you want to refer to it as, but this area below is the basement that we were standing in, and then the whole main floor goes across here. We'll pan around in a minute and show you a couple different things, but when we start talking about floor sheathing, there's a few different types of materials that can be used. And depending on what level of home you're building, you may see different types of floor sheathing. Different parts of the country, you're going to see different types of sheathing. And then also, you have to follow what the plans and the engineer has spec'd out in the typically in the general structural notes or the GSN. A lot of times it's going to tell you the floor diaphragm thickness, the nailing, field and edge nailing, and whether or not glue is required or some sort of subfloor adhesive is required. Sometimes it's required that it be screwed versus a ring shank nail. So all that stuff is going to be spelled out in the general structural notes typically, or within the details in the plan. So it's important to understand not only the materials that you're working with, but also how they're supposed to be fastened to our floor framing assembly, whether they're, again, trusses conventionally framed or the I-joists. And you can see behind me here, we've got these open web floor trusses, and one of the things that I didn't mention was the fact that they're a 4x2 truss, meaning that the top and bottom chord are 4 inches, essentially they're a 2x4. It gives a lot more area for nailing and screwing to. You've got 3.5 inches, whereas some of these I-joists behind me, you've got roughly about 2 inches, and then if you're talking about conventional lumber, you're only talking about 1.5 inches. So anytime you break a panel on a joint, the wider the better. It's going to help with that nailing. It's also going to allow you to put more adhesive down and ultimately create a stiffer floor diaphragm. So when we talk about different types of floor sheathing, there's basically a couple different kinds. There's more of your traditional OSB oriented strand board, where it's a manufactured product. It's basically manufactured under intense pressure with a specific glue that bonds everything together. It does work well. It's probably the most common roof and wall sheathing and even floor sheathing that is probably generally used across the country. And it really, again, depends on the project that you're working on, the level of, cost that's related to that project. We typically will not use normal OSB sheathing. The other thing that can be used and is often used, especially on a floor sheathing, is a typical plywood, where plywood's manufactured with the grain going every different direction, which basically makes a very, very strong floor. And the last thing, and what we're going to be talking about here, is a product made by Huber. It's an Advantech subfloor system, where if you use their specific subfloor adhesive along with their product, their sheathing, whether it's 3/4 or 1 1/8 inch like we have here, you get a 10-year structural no squeak guarantee, and we're going to talk about that in a little bit. And this particular product, we're out here in Arizona where it doesn't rain, but when it rains, it typically rains a lot, and we're in the middle of monsoon season, and here we are framing a floor assembly. It's besides maybe the winter time when we're getting our winter rains, this is probably the second worst time to be, trying to install a floor system because it is going to get wet. And when it rains out here, sometimes we may get 1 inch or 2 of rain during a monsoon season, and that water is not, this floor that I'm standing on is not pitched to drain water off. So you may get ponding water up here during one of these heavy storms. So this product by Advantech does an excellent job. They've got a resin inside of it that basically allows for a 500-day exposure guarantee, meaning we can leave this thing exposed to the weather, the sun, which is very intense here, and to these multiple monsoons that we're going to get through this process, through this framing stage, before we get this building dried in. And that's a huge advantage to us, because on a project like this, the framing may take 8 weeks, and that's just for the framing. For us to then get the roof dried in and the walls dried in, it may take a couple more months. So this building is really exposed and open to delamination and other problems that can occur from general weather, especially the harsh sun and the monsoon season that we get here. It can be very damaging to products. And if you're using inferior type of products, you're going to expect buckling and warping and delamination And so I want to talk a little bit about the Advantech product that we chose here. And again, ultimately, it's best practice for us. It completely, I should say completely, but just about eliminates all of our liability and potential for callbacks. Again, these squeaks can be costly. The last thing we want is a callback after the house is all done and that customer is experiencing a squeak somewhere in the floor. Those things are hard to find. And when we go to repair them, they're very intrusive, meaning we've got to typically cut drywall up, remove flooring on the top side, just to try to locate the squeak, let alone do the actual repair. So it's very important that you pick a system, again, that works as an assembly, a floor framing assembly, meaning whatever your floor framing member is, open web trusses, along with that sheathing, those two need to act together as one rigid structure to eliminate those callbacks. And again, the best practice of using what we feel is the best product for this particular job. So let's talk a little bit about the Advantech product. These things are very flat. I think all the research that I've done, Huber does an amazing job with their manufacturing process and the quality of the product and how flat and square these panels are. They also come with a built-in spacer, which, if you're talking about traditional OSB or plywood, typically what guys will do is they'll stick an 8-penny or 16-penny nail between the panels to allow for expansion. If you actually read the instructions by the manufacturer, and the same thing goes on the sheathing on the outside of the building, they will actually tell you to have those gaps built in so that it doesn't create cracks in the stucco or cracks in the flooring because things don't have any room to move. So Advantech has done an excellent job where they actually have that built-in groove, which it's just trying to take some of the effort out of the framer, less thinking. So if a guy forgets the gaps in plywood, the only solution to it is to go with a circular saw and run it down the edge to create that gap. So they've done an excellent job of trying to think through those things that make it easier and ultimately will reduce some labor. And I'll show you here on the plywood where they've got nailing patterns all laid out, which is just very helpful for the framers, less chalking out of lines to know where their nailing patterns need to be. So they've done an excellent job with that. Again, they're very flat, precise, and square, which again helps immensely when we're trying to lay this deck out up here. Again, I think their testing that they do is above and beyond multiple manufacturers, and there's other manufacturers that create a sheathing like this, the same thickness and some of the similar resins to help with moisture and things like that. But all the research we've done, this is the best product out there. It does give you that 500-day guarantee for leaving it exposed to the weather. And it's also, the other big thing is that this whole floor can be fastened with a nail gun. We're using a ring shank nail, and we're using that instead of screws, and it'll decrease the labor on this deck by probably 50 to 60%. Once that ring shank nail penetrates that framing member along with this subfloor adhesive by Advantech, you've got the best practice, the best guarantee that you're not going to get a call back for squeaks. So extremely important to us overall, but also delivering that great product to the customer that when they're spending this kind of money, they deserve that. So let's see what else. So again, yeah, when you pair it with the Advantech subfloor adhesive, you do get a 10-year squeak-free guarantee. So those two things, the 500-day weather guarantee is a big one because it has that moisture-resistant resin technology that they have built into this OSB product that allows us to keep this exposed to the weather during long framing and times when we can't get the building dried in quite as fast. So as we talk about the sheathing, we've got to obviously use fasteners to attach it to our framing members, but in conjunction with a subfloor adhesive, is extremely important for reducing those squeaks. And for years, the best practice or the most common practice was to use a solvent-based glue in a big traditional caulk gun. That those caulk guns are very hard to use, and over time, as the day rolls on, guys' hands are going to get sore from using them. You typically, if it's cold outside, the way we used to do it was we would bring the actual glue into our house at night. During the winters, we don't experience quite that out here, but what I'm getting at is that glue gets really, really hard to pump through a caulk gun. And those are all solvent-based adhesives. So what Advantech has done is they've come up with this subfloor adhesive that's basically a gel, and it does an excellent job of not only attaching it amazingly to whatever structure you're bonding it to. There's been tests done where guys have tried to rip this stuff apart, and whether it's plywood or OSB, that stuff's coming apart in a million pieces. So they do an excellent job of creating a product that the bonding capacity is absolutely unbelievable. And you do get some extra structural capacity to your floor diaphragm with glue, but we typically use it whether it's called out on the structural notes or not, because again, we're trying to do the best practice, but also reduce our liability. And I'll show you how this stuff gets applied through their caulk gun. It's just an excellent way to apply it. It's basically very easy to use. The guys love using it. They claim that you get 8 tubes of of this solvent base, whether it's a liquid nail or some sort of PL type adhesive. They're saying you get eight tubes to one of their cans. We think it's a little bit less than that, and maybe it's because we're using more glue. But at the end of the day, glue and nails are cheap comparative to squeaks.
So years ago, most of the houses converted to building homes and doing their framing at 16 inches on center, giving the people the idea that the homes are much better structurally built and more sound. But what we've learned over time is that by stacking framing members at 24 inches on center, which is the spacing of your trusses, we actually can reduce the amount of lumber in a building and also add extra insulation inside the building. So that's what you're seeing here. If you look, you can kind of see the vertical wall member, which is the vertical stud, is stacked directly below the truss, and the load path is straight through from the roof all the way to the foundation. Again, that allows for less lumber and more insulation. The other thing that you're going to notice here is that our headers are a little bit taller, but they're single ply. So structurally, it gives the same value, but from an insulation perspective, what you can see from the side here is that you've actually got room to put insulation inside there, which again, if you looked at things with a thermal camera years ago, you would see a big void in these areas. And so nowadays what we're doing is we're pushing that header to the outside of the building, creating a space above the window or door, and that allows us to put insulation in there. So we'll come back with an infrared camera after all the drywall's up and the house has had the air conditioning turned on, and we'll be able to show you what the difference is there.